Today we're going to be discussing Unit 8, Topic 2, Parallelograms. Well, what is a parallelogram? First, it's a special quadrilateral. And if you remember, a polygon with four sides whose angles sum to 360 degrees is a quadrilateral. That means that every parallelogram is going to have an interior angle sum of 360 degrees. So what exactly is a parallelogram? Well, a parallel, notice the word parallel is in there, ogram is a quadrilateral with both pairs of opposite sides parallel. And don't forget the symbol for parallel is the double L. Also, notice that when we talk about parallelograms and parallel, we use arrows to show us that these sides are parallel to each other. So what mathematicians do is we look at this parallelogram and we say, well, what happens to this shape when the sides become parallel? So what happens is we get four properties. Now the first property is that my opposite angles are congruent. And that means that this angle would be congruent to this angle. And this angle would be congruent to this one. So when I see a picture and it looks like this, that's telling me that my opposite angles are congruent. Property number 2 tells me that opposite sides are congruent. And when I mark congruent sides, I use hash marks instead of arrows. So my opposite sides are congruent. Property number 3 tells me that the diagonals bisect each other. So first of all, what's a diagonal? A diagonal is when you connect one vertice to the opposite vertice. So we're going to go ahead and do that now. If you notice, I drew in my diagonals of that parallelogram. Now to bisect means to cut into two congruent pieces. So if I look at this long diagonal first, this piece is equal to this piece. Also, the other diagonal is also bisected. Now our last property of a parallelogram is one set of opposite sides is both parallel and congruent. So if I pick one side, I can put the hash marks to show that it's congruent, and I'll draw in an arrow to show that it's parallel. So those are my four properties of a parallelogram, besides the definition. So now what do I do with that? We're going to have to be able to figure out if things are parallelograms using these properties. So let's look at 3 sample problems. First, is this quadrilateral a parallelogram? And if it's yes, I have to say why. So if I look back at my properties, I'm going to see which picture kind of looks like the example. So when I look, it kind of looks like property 2. So if I go back, I'm going to say, yes, this is a parallelogram. And why? Because my opposite sides are congruent. So let's look at the next example. If I look at the next example, I'm trying to figure out if this picture matches one of these or the definition, of course. So I look, and it looks like I have arrows and hash marks, but they're not on the same line. The closest I get is property number 4, because I have both of those, but they're on the same set of opposite sides. So I don't think that this is a parallelogram. Not a parallelogram. So I don't have to name a property if it's not true. So if I look at the next one, now I'm going to go back to my properties again, and does this look like any of these? I think it looks like property number 1 because I have hash marks on my opposite angles. So if I go back to this problem, my opposite angles are congruent. So is this a parallelogram? Yes. Why is it a parallelogram? Because my opposite angles are congruent. So now you can determine whether or not things are parallelograms. So try the next few problems.